Welcome to this introduction to our web interface for iterative dataset labeling using artificial intelligence. In this example, we'll focus on labeling E. coli in microscopic images. We begin by creating a new project. To do this, we open the corresponding interface. In the next step, we give our project a title and a short description. Here, our goal is to detect E. coli in microscopic images. These details will help us keep our projects organized later on. With one click, we create the project and are taken directly to the project detail view. The overview shows all relevant information, and from here we can manage already uploaded image sets. In the upload area, we can add our first images. First, we select 10 images from our computer. We start with a small number because we cannot yet expect support from the AI model. After all, it hasn't been trained on E. coli yet, so we can just stick with the default settings and start uploading the images. After a short time, the status of the image set changes from uploaded to annotated. This means the model has already tried to detect objects in the images, but as expected at this point, it hasn't returned any results. So, we switch to the annotation tool to label the images manually. Here you can see exactly how we use bounding boxes to mark the areas and then name them correctly, creating our training material. In the bottom right, you'll see a timer measuring how long it takes us to fully annotate all 10 images manually. Since this usually takes a few minutes, I'll fast forward this process. That way we can move right on to the next step. We're placing one last bounding box on the final image. Perfect. Now we have 10 fully annotated images that we can use to train our AI model. Let's move on to the training interface to start the training process and create a new model snapshot. On the right, you see the image set we just annotated. It's ready for training. On the left, we can name the snapshot and, if we want, choose a previous snapshot as a base. For now, we'll start with the default model. We also have the option here to set our training parameters. We'll run the training with 250 epochs, a batch size of 20, and a learning rate of 0.0001. We then land on the snapshot overview, where the learning loss is displayed at regular intervals. This allows us to directly track how the model is developing. I'll spare you the wait and fast forward to the training results. After 250 epochs, the training is now complete. We can see that the loss value has decreased nicely. That's a sign of successful training and suggests that the model will likely recognize E. coli in future images. We also see additional metrics here, such as the normalized loss per epoch, the per epoch change, and the cumulative trend. For our purposes, this overview is usually sufficient. If we're happy with the results, we move on to the first iterative step. We upload the next image set and use the trained model for support. Next, we switch back to the interface where we upload new images and choose another 10 images from our computer to add to the project. The most recently created snapshot, so the saved version of our trained AI model, is automatically selected for this upload. We start the upload with a confidence threshold of 0.3. That means any object the model detects with at least 30% probability will be accepted. When we look at the results, we notice something called overfitting. This means our model has focused too intensely on the images it has already seen and is now making many inaccurate suggestions. In other words, there are a lot of generated annotations per object, indicating uncertainty in the model. Since it would be very time-consuming to correct all these inaccurate markings by hand, we delete this second set of images and try again. We again select the same images from our computer, but this time we set the confidence threshold to 0.4. This means we only accept proposals where the model is a bit more certain. The results are now much better. Many of the markings are already correct or only need minor adjustments. The time-lapse shows how the AI supports the user during annotation and makes the process easier compared to the first round. After about 7 minutes and 20 seconds, we've revised all 10 images, a bit over a minute faster than our first fully manual attempt. This is despite the fact that this time there were generally more E. coli bacteria to label per image. With these extended data, we start a new model training based on our first snapshot. We keep the same training settings, the number of epochs, and the size of each training batch, for now. The second training, compared to the first, has a smaller impact on the model's performance. We therefore see fewer improvements than before. Still, the training is now complete, and we can start a third iteration by uploading another third image set. For this third round, we once again choose the next 10 images from our computer. The latest training snapshot is already selected as the model. I'm only lowering the confidence threshold to 0.2. After the previous overfitting issue, the model now places its bounding boxes more accurately but is also more cautious with how many objects it suggests. As you can see, the model is already recognizing E. coli bacteria quite well, just with a slightly lower confidence level per suggestion. On the plus side, we have far fewer annotations to correct, which reduces our workload significantly. Even though we still had to label a few objects ourselves, we finished all 10 images in just 3 minutes and 47 seconds. Before starting the next training, we adjust our settings. We increase the batch size to 50 and reduce the number of epochs. We also lower the learning rate for the first time, but we notice that the error rate barely improves. Even at the end of training, the change is minimal, so that round of model training wasn't particularly successful, and we start an alternative training session. We give this new snapshot a clear name to avoid confusion, and then use the last good snapshot as our base. At the same time, we revert our training parameters to the previous values. This subsequent training goes a bit better. As soon as training is finished, we compare both snapshots. The newer alternative snapshot shows better results, so we decide to continue with it. We now upload the next set of 10 images, making sure to use our latest snapshot for detection. We set the confidence threshold back to 0.3 since the model has now been trained further. It should therefore be more reliable in its predictions. During the subsequent edits, we take noticeably less time than in the first 3 attempts. In just 2.5 minutes, all 10 images are fully annotated. A real improvement. Thanks for your attention. Have fun trying this out yourself. If you have any questions, feel free to visit us on GitHub. See you soon.